This puzzle is called 8 Crazy Nights by rockratzero. Got it from the Sudoku testing submissions channel of the CTC community Discord. Let's take a look at the rules. So we have palindromes. So the gray lines are palindromes, so they must read the same backwards and forwards. So what that means is, like the word race car, if you don't know what a palindrome is, the word race car, you can write it forwards, or if you write it backwards, it's still the word race car. That sort of thing. So, um, if you read this line, if you read this yellow line forwards or backwards, it needs to be the same. So whatever digit is here at the beginning needs to also be at the end, and then this digit needs to be the same, and then this digit can be whatever since it's, right in the middle. Um, let's look at this one is a little bit more complicated. So like these two kind of pink ones are the same. These ones are the same. Whoops. Sorry. These two ones on the end are the same. Then the next one are the same. And then the green ones are the same as well. And then this one's in the middle, so it can be whatever it wants to be. Okay. So then we have 8 killer night cages, digits in a cage summed to the small value given in the top left of the cage. So these 4 digits add up to 27, these 4 digits add up to 23, 17, 14, and so on. Digits cannot repeat in a cage, so let me find right here. So these two digits could not both be 9, for example, because they're in the same cage. Obviously, normally they could be 9, like these two could be 9, that would be just fine. But because these are in the same cage, they can't be both 9. Additionally, each cage must contain an 8. Okay, that will make things interesting, so it must have an 8. Every cage has to have an 8. Additionally, each palindrome represents the 8 nights... Oh, of Hanukkah, yeah, the 8 nights of Hanukkah, I believe, right? By beginning and ending on the digits 1 through 8. So I believe that means that, like, let's say this one begins and ends with the digit 1, then no other palindrome will have 1 on the ends, but somewhere over here, let's say here we'll have 2, and then we'll have 3, maybe 4 here, then 5, 6, 7, 8. 1 each for 1 through 8. I don't know how hard this puzzle is, but I'll put a link to the puzzle down below in the description if you want to give it a try. Yeah, let's get started. So the first thing I see is this killer cage here. 14 and 4 cells is a little restricted, but not that restricted until you remember that each cage must contain an 8. So once we put an 8 in here, now obviously we don't know which cell it goes in, I'm just putting it there. The other 3 digits must add up to 6, and if we add up the very minimum digits, that's 1, 2, and 3, that adds up to 6. So we know that the 4 digits in this cage must be 8, 1, 2, and 3. Um, let's see. Okay, so here's another thing. Let me see just how I want to illustrate this. So in the 26 cage and in the 17 cage, yellow and pink, there's going to be an 8 in each one of these, right? Now in these full rows, rows 4 and 5, we're going to have 1 8 in each of them, right? Because each row has the digits 1 to 9 exactly once each. So we'll have 1 1 in row 4, 1 1 in row 5. That's total. That's all we get. That's all we get. Well, where are the 8s going to go in rows 4 and 5? Well, we need one of them for yellow. We need one of them for pink. So we actually can't put any 8s in... Oh, gray does not look good with that palindrome. In blue. We can't have any 8s in blue, because we've already kind of reserved... Sorry, one second. Throat got really scratchy there all of a sudden. We've already reserved... that's the word I like to use at least. We've already reserved the 8s in these 2 rows in yellow and pink. So then we look at this 20 clue, and we need an 8 in this cage. Well, where can we put the 8 in this cage? Well, it can't go in blue, so it must go there. That's going to be an 8, which then is going to put an 8 there because it's on the palindrome. And this can't be an 8, because this 8 sees that, of course. And I think we can do this, the same thing right down here. So in rows, what is that, 6 and 7, again, we have 2 8s total. That's all the 8s we get. And we need one for pink, we need one for yellow, so we don't have any more to use in this dark blue region, or this dark blue area, which is then obviously going to constrict this 29 cage. We need an 8 in there, so that 8 must go there, which is going to put an 8 here. And we actually have the 8 palindrome, because each palindrome kind of has a number based on what's on the ends. So this palindrome is the 8 palindrome. We can't put an 8 on the end of any more palindromes. Okay. I'm just looking. A lot of these palindromes like overlap these killer cages a lot. So I was trying to think if we could, you know, force an 8 somewhere, but I don't think we can. Well, this can't be an 8, because we literally just put an 8 right there. So we need an 8. I guess it's just going to be along there. That's not too helpful. We know that there has to be an 8 in here anyway. Oh, this has to be an 8 now. Where can we put an 8 in the 26 cage? This 8 rules out row 4, so it must be right here. Which then we look at this cage. This needs an 8. This needs to be right there. Then we can put this, whoops, that was supposed to be an 8. And then we can put an 8 in the 27 cage. This can't be an 8, so then we place the last 8. And there we go. That's all the 8s, I think. If I can count to 9, that's all the 8s. Yep. Okay. So what can this digit be? Is that something we need to look at right now? I don't know. It's where I'm looking. So what can this digit even be? This could be a 4, 5. It can't be a 6. Could be a 7, but can't be a 9 because the end digits must be 1 through 8. So 4, 5, 7. That's not that helpful. Not helpful at all, I guess I should say. That's okay. 29 must be 6. Sorry, not 6. 5, 7, 8, 9. In order to make 29, that's the only way to make 29 in 4 digits. And we've already placed the 8, so it's just 5, 7, 9. Okay, I think that's... There's 2 ways of making 28 in 4 cages. We could do 4, 7, 8, 9, or we could do 5, 6, 8, 9. Unfortunately, I don't think there's any way of, at least at the moment, of seeing which way around those are. Yeah, I don't see any way to figure that out at the moment. So what could this digit be? Maybe that's would be helpful. So this could be 1, 2, 3, 4. It can't be 5 because if we put a 5 here, whoops, if we put a 5 here, then we couldn't put a 5 in this cage, and it needs a 5. It can't be 6 because of the 6. Again, we can't do it with 7 because it would rule 7 out of the whole cage. 8s are already placed, and 9, it can't be 9 anyway. So this is a 1, 2, 3, or 4. It's not super helpful either. Feels like there's something else going on that I'm just not getting. Oh, here's something. Okay, this will give us a digit. So let's look at this area. This area adds up to, let's see, 46 plus, that'll be 66 minus 3, that'll be 63. So pink in full adds up to 63. How can we use that? Well, we know that each row, let's just make these yellow. Each row, column, and region in Sudoku contains the digits 1 to 9 exactly once each. If we add up all those digits, 1 plus 2 plus 3 plus 4, all the way up to 9, we get 45. That means that yellow here has a sum of 45. So yellow plus pink we said was 63. If we remove yellow, we now have, oh my gosh, 1 second. It's only like 8 p.m. But for whatever reason, I feel like it's too late to do math in my head. Let's just write this all down. 26 plus 20 plus 17 equals, what did I say, 63? Yeah, 63. So pink plus yellow equals 63. Let's just highlight this yellow once again so you can tell exactly what I'm talking about. Yellow equals 45, so pink equals 63 minus 45. So pink equals, that'd be 18. Yeah, so pink equals 18. Well, we have an 8, we have an 8. That's 16, this must be a 2. Which is, to finish off these boxes. Just some simple maths. Okay, so this can't be a 2, which means this can't be a 2. And more importantly, these can't be a 2, so this is a 2. Yeah, I think that's where I was supposed to look, because I immediately see something else. This 1, 3 is looking down into box 9. So where can we put 1 and 3 in box 9? It can't be along here or anywhere we've already kind of figured out. So it must be right there. And then we can move that along the palindrome to over there. Let me hide Notepad once again. Okay. Okay, so now where can we put 1 and 3 in box whatever this is, 6, box 6. We now have the 1 3 pair looking up. We have this 1 3 pair looking down. And this can't be a 1 or a 3, so 1 and 3 need to go into these two cells. So this is a 1 or a 3. This can't be a 4 any longer. Fortunately, that's the middle digit, isn't it? Yeah. So we can't do anything with this palindrome. Oh, this one can't be a 4 any longer. Okay. So we have a 1 3 pair here. What does that do for us? Guess it means neither of these end in a 1 or a 3. Oh, interestingly, I don't know how we can use this fact, but I think it might be important. Or maybe it doesn't matter. One of the two. It's either important or doesn't matter. So this 2 rules a 2 out of here. Also, these two cells can't be 2. That's going to put a 2 in one of these cells, which we can do slightly better than that, actually. But one of these cells is going to be a 2, which is going to be the end of a palindrome. So that will make one of these palindromes a 2 palindrome. But that's basically all the palindromes that are left. So I don't know if that's actually helpful. Now, it can't actually be this one, because if this was a 2, F-Puzzles already realizes it's wrong, then this would be a 2, and we have two 2s, so that's not going to work. Oops. So we actually have 2 in just 3 spots. Here, here, or here, I don't see any problem with the other ends of the other palindromes. Could this be a 2? If this was a 2, this would be 10. We would need these to add up to 10. This would be a 7. This would have to be a 7, yeah, because we can't do a 9 on the end of a palindrome. That seems to work just fine, as far as I can tell. 2 and 8 is the other option. I guess either way, it's going to be 2 and 8, which would make the other thing a 13 pair. And there's 2 other 13 pairs we haven't used. 8 does use up one of the 3 options, but 4, 9, and 6, 7 both work just fine. Okay. Well, how about this? No, I was going to say, could we rule 2 out of up here, but we cannot quite do that. The most you can add up 3 digits to would be 9, 8, and 7, which is 24. So theoretically, we could do 2, 7, and 9 up here to use a 2 and just barely fit in to this 26 cage. Because if we could rule a 2 out of up here, then the only place to put a 2 in this row would be right here. But I don't see that we can quite do that, unfortunately. So what do I need to do now? These 2 digits are the same. That's actually super restricted, actually. Okay, so it can't be 1, 2, or 3 because of the 1, 2, 3 up here. I think it could be 4. But now I don't think it could be 5, because if this was a 5, then we couldn't put a 5 into this triplet right here into the 29 cage. Because it would, just by the rows, it would rule out the 5s from all those spots. So I don't think it can be 5. There's a 6 right here ruling it out from both of them. Again with the 7s, it can't be 7s. It can't be 8, we've already placed the 8s. And again with the 9s, it can't be 9 either, because we need a 9 in here. So it must be 4. Unfortunately, that's not the end of a... keep wanting to call them thermos, but they're not thermos, they're palindromes. If I've already called them thermos, I apologize. For whatever reason, I just can't. My head is thermode right now. But yeah, so it's not on the end of the palindrome, which is fine. It still gives us information, but not as much as we would have liked. Okay. So what about this 17 cage? We have 10 already. So this has to add up to 7. It's either 1 6 or 3 4. We just put the 4 in, so this is a 6 1, which is going to give us a couple of these 1 3s at least. So now we have the 3s done. So we know we can't put a 3 on the end of any other thermos. I don't actually think we could have put a 3 on any of the other thermos just by Sudoku, because all of these 3s, these 2 3s that we have see at least one end of every single thermo, I think. Well, that's fine. Let's see. This is 5, 7. What's left in... A 6 and a 9 must go in here. So this can't be 9. I guess this is 5, 7, 6, 9. That's a better way to... So this is a 5, 7, 6, or a 9. Because these two are the same digit. I don't think that matters much. Let me look at some combinations. I think this is getting pretty restricted here. So we need 26 and 4 cells. 26 and 4 cells right here. And let me put Notepad back up so we can see the combinations pretty easily. Come on. All the way to the left. Okay, there we go. So we have an 8. We must have an 8 in there, so we can remove one of the options. We can't have a 3. We can't have a 6. Oh, it's not actually that restricted. I was hoping... I mean, it's a bit restricted, but I was hoping it would be totally, just one option. So we know there's a 9 across here. And actually, we know there's a 9 looking down, so this can't be a 9. There has to be a 9 in a 28 cage. If this is a 9, then this is a 9. I think that would be fine. If this is a 9, that's the middle, so that's fine, yeah. What about this cage right here, the 20 cage? We have an 8 and a 3, so that's 11. We need this to add to 9. We can't do 1 8. We could do 2 7. So this could be 2 7. We can't do 3 6. And it could be 4 5. Is there any reason why one of those wouldn't work? Oh, this one can't be a 4. So this can't be a 4, this can't be a 5. This is a 5 or a 7. Yeah, and this is a 2 or a 4. Right, 11 plus 9. Let me hide this again. 11 plus 9 equals 20. Yeah, that should be good. I feel like I'm going to mess up math. I don't know if I've really done that before in a video, but one of these days I'm going to mess up the math really badly. And no, I did do that in one video. A Mad Tyus puzzle. I was saying 9 plus 9 equals 19 for quite a while on it. As you might have guessed, 9 plus 9 does not equal 19. So it caused me a lot of problems. Let's see. This is a... Wait, so I said 9 had to be in here, so this can't be a 9. This is just a 6. Which makes this a 1. So now we have the 1 done. And this must be a 1 because it's the last spot in the box for a 1. Yeah, okay. This can't be... This can't be a 1. That could be a 1. This could be 1, yep. Actually, this can't be a 1 because of the 1 3 pair. So one of those is a 1, but I don't know how much that actually helps. Yeah, those are fine. Okay. What were the options for that? No, that doesn't... Yeah, it's literally whichever pair here we don't use is going to be the pair in here that we need. What about 28 in what am I trying to say? 28 and 4, it's going to be 9 plus 8 plus an 11 pair. So either 5 6 or 4 7. We can't do 5 6 because we have this 6 here, so it must be 4 7. 4 7 9. This can't be a 4 because of the 4 over here. Wait, let me bring this back up. So this cell can't be any of a lot of the digits. What digits can this be? It could be a 2, 3, it could be a 5. Oh, darn, actually. Okay, well, I think that's all. It can't be a 6, it can't be a 7, it can't be an 8, it can't be a 9, yeah. Okay, well, I thought that was going to be helpful. Does not look like that's going to be helpful. Where should we look? What killer cages have we... It's 27 cage. 27 has a number of options. I guess does 27 have to have a 9 in it? 27 and 4 does have to have a 9 in it. Let me just cut and paste these so we can see them and think about them together. So below the dashed line is the 27 and 4 options, so it must have a 9. This can't be a 9 because we need a 9 up here. This can't be a 9 because we have a 9 up here. So this must be the 9, which means this can't be a 9 and makes this a 9. And whoops, that's the wrong digit. That's supposed to be a 5, 7. To finish off the box, we need a 5, 7. Oh, this is just a 9. I could have done that a while ago. When I realized this was a 1, 6. What's left is 2, 4, and 6. Right, and then this is 2, 4, 6 theoretically, but we see a 6 up there, so this is just 2 or 4. We now have a 2, 4 pair. This is the 6, so this is a 6. This can't be a 6, so this can't be a 6, which... No, that does not make this a 6. One of these is a 6, but we don't know which. Yeah, that's fine. So these have to add to 10, so this is either 4, 6, or 3, 7. This can't be a 7, so this can't be a 3. This can't be a 7 because of this pair, so this can't be a 3, and this can't be a 6. So this is a 4, this is a 6. That actually worked out. Okay, so this is a 2, this is a 4. So this is a 5, because this needs to add to 9. Follow this around, this is a 5. This is a 2, this needs a 7 and a 9 to finish that off. And we need a 3. Great. Oh, and then we can... This is just a 2. Let's look at this cage right here. 10 plus 6 is 16. You need a 7. Which actually just puts a 7 right there. This 7 is going to figure out the... Whoops. Going to figure out the 5, 7 pairs over here. So this is a 7. This is a 7. This is not a 7. This 7, 9 is also 7, 9 right there, I think. Yeah. Whoops. I accidentally removed it while I was adding it. Now I have a 7, 9 pair, so this can't be a 9. This is a 5, which makes this a 5. Okay. This 4 is looking over here, so this must be the 4. This 7 is looking over, so we can figure out a little bit more. This is a 9, this is a 9, this is a 7. This is a 4. 3, 5. 1, 2, and 3 is left in this row. So this palindrome makes this a 1, 2, or 3. And it can't be a 1 or a 2. So this is a 3, which is going to figure out a lot of the rest of the puzzle. This 9 is looking over. We could have done that, but I missed it. This must be a 5. What's left here is a 5, which must go down there, and a 6. Then we need a 7, and that 7 figures that out, and then we need a 1. So this can't be a 1 any longer, putting the 1 here. Figuring out the rest of those 1, 3s. 1, 2, 3. We need a 4, 7, 9, which puts the 4 there because we have 7 and 9 in the row. 7 must end up there, and then a 9. This 5 puts it like this. 4, 2, 3, and 9. I think that's how we figure that ending bit out. And I think that should be the puzzle. We have our 1 palindrome here. 2. Where was 2? 2 was right along here. 3. Yep, there we go. 3 will make pink again. 4 is right here. We'll make green. 5 will make blue. 6 will make green again. 7 is looped through here, can be yellow, and then 8 can be blue. There we go. Oh yeah, I didn't even notice until I colored these in that it's making the menorah, right? I'm not super familiar with Hanukkah, but that's the candle holder, I think. Hopefully I'm not too wrong on that. Yeah, I didn't notice that they put those all together like that. That was a very nice puzzle. Thank you, rockratzero. That was a fun mixing of killer cages and palindromes. Yeah, so thank you for the puzzle, and thank you all for watching.